All right, my friends, for number 11, it says let R be the region between the graph of y equals e to the negative 2x and the x-axis for x values greater than or equal to 3. They want to know what the area of region R is. I would recommend that you think graphically about this one. So I'm just going to go ahead and think about what would the graph of e to the negative 2x look like? Well, it would be an exponential decay function. So here's a little kind of quick sketch as to what that would look like. And then they want to know, like, if you start at 3, let's say 3 is here, if you were to find the value of this bounded area between the graph and the x-axis from 3 to infinity, essentially. Now, fight the urge to say that the answer is infinity. Remember that if these heights go to 0 fast enough, then even though you're adding up infinitely many of them, you could still get something finite. And so I'd recommend setting up an improper integral to evaluate the sucker. So I would say the area would equal the integral from 3 to infinity of e to the negative 2x dx. And then up to you how you want to evaluate it. Everybody has their own style. So I would rewrite this as the limit as b approaches infinity from the integral from 3 to b. And then totally up to you how you want to go about that, that antiderivative. You could do u substitution and change your bounds. You could do the antiderivative in your head, which is what I'm about to do. So the antiderivative of e to the negative 2x would be e to the negative 2x, but then you'd have to have like a negative 1/2 in front of it for chain rule purposes to get this when you take the derivative of it again. So we'd end up with the limit as b approaches infinity of negative 1/2 e to the negative 2x from 3 to b. All right, and then little fundamental theorem of calculus work. You're going to plug b in for x, plug 3 in for x, and subtract the results. When I plug b in for x, I'm going to also take care of the negative exponent. So I'd have negative 1 over 2e to the 2b. And then we're subtracting a negative, so we're basically adding 1 over 2e to the 6th. So hopefully that makes sense. I just plugged 3 in for x. And then if you let b approach infinity, hopefully now that I took care of the negative exponent, it's pretty clear that this would go to 0, that whole expression there. And so we'd just be left with this constant right here. There we go, which matches with option A.